Hello, hello, hello. Today we're going to work on some exercises of algebra and we're going to work out on some basic algebra. We're not going to do like something very difficult, just the beginning of algebra. I'm just going to put here the hello message. Hello. And I'm gonna write in this chat, in the chat of the video, in the live session, I'm gonna write every time we work out a different topic, so you can, every time you need to work it out, you can just check the chat, and by checking the live chat you can see where each time is given. Okay, so we're gonna start working with this, and we're gonna start with algebra by doing converting into algebraic language. To convert into algebraic language, the first thing you need to identify are the letters or the ideas or the words that tells you that you have an operation. So in this case, for example, I can see that the word quotient refers to an operation, and I can see that the word twice refers to an operation, and the word number refers to a variable, right? So I have here three words that helps me to know what I'm doing. It's the quotient, so it's an operation. Twice is another operation, and a number that it's a variable. So essentially what it's telling is the quotient is division. So it means that I have to divide twice means two times. But two times what? Two times a number. So the number is 10 and 15. So basically what I have to do is twice the number, two times the number n, divided 15. This is the quotient of 2n, of twice a number and 15. Let's see, for example, what happened with question E of this one, that it says subtract P from Q. Subtract. So the operation of subtract means subtraction, obviously. P from Q. So I need to take Q. I have a number Q. And I'm going to take from this number Q the number P. So this is what I want to get. So it's going to be Q minus P in this case. And this is how you can convert to any algebraic language any number. For example, we're going to see in D that it says more than, and I have here half, and I have here a number. So in this case, it says 24 more than. In this case, it's addition because I'm representing an expression. Addition. Half means multiply by 1/2. And the number will be n, right? So as this is addition, but it says more than, means that this expression goes first. So it's going to be 1/2 of n plus 25. This is how you can convert into algebraic language any number. This is how you can work it out. This is how you can start working on converting into algebraic language. Now let's see another example. Let's see more working of algebra, basic algebra. What happened if we gotta do an exercise like exercise C that appears here, that it says that I gotta do 3f plus 4g when f is 2 and g is 5. So essentially what I have to do is just to replace the value f by 2 and to replace the value g by -5. This is the idea. This is what you gotta do. Now, remember that in algebra, when you put a coefficient and a variable, what you're saying is that you're multiplying these numbers. So essentially, this is a multiplication. This is like writing 3 times f, but in this case, f is 2. So 3 times 2 plus 4 times -5. So 4 times -5. So I'm just going to perform this operation. 3 times 2 is 6 plus 5 times -5 is -20. And I just need to do 6 plus -20. So imagine that you have 6 Then you put negative 20 because you're going to add 6 plus negative 20. And the number is going to be this negative number. This negative number completes 20 by 6. So it's going to be negative 14. So the answer is going to be negative 14. So this is how you can evaluate in an expression. This is how you can work out the evaluation of an expression. So we just did this part. So converting to algebra and evaluating expressions. We just did it here in the minute 6 until minute 6 until 6:30 seconds. Okay. Now this is how you can work out algebra to converting to expressions or evaluate expressions. Now let's continue with the next questions that you can see, type of questions, that is, what happened if you're asked to simplify expressions? When you're asked to simplify expressions, what you gotta do is to identify like terms first. Like terms. Like terms are variables with the same power. For example, this x, I have the same variables with the same power. So essentially, what I just need to do is like imagine that I have 6 centimeters minus 10 centimeters minus 6 centimeters, or 10 cats minus 6 cats. In this case, it's 10x minus 6x is going to be 4x. This is how you can identify this work so far. So what happens if I have 5a minus 8a? So I identify the like term, a. So in this case, I just need to 5a minus 8a. So it's like having $5 minus $8. So I'm gonna be minus $3 of debt, right? This is how you can identify like terms. Look at here, this term with this term. These two are like terms, but these two are not like terms with 12 and 4 because these two have no variables. So I cannot add them like all together. I must add only the 12m minus the 4m, and I need to add the 16 minus the 24. Remember that the sign corresponds to the term as well. So I'm going to do 12m minus 4m, as we have like terms, 12 minus 46, so this is going to be 8m. Now 16 minus 24, 16 minus 24, it's going to be just the subtraction of 8. So 16 minus 24 is negative 8. And here I have 8m minus 8. That will be the simplest form of this one. Now, when you have a parenthesis, finally, when you have a parenthesis, you must apply distributive property. So what I gotta do is to take 3 times x and 3 times negative 15. So essentially is to put 3 times x minus 3 times 5. And this is just 3 times x is 3x, and 3 times 5 is 15, so minus 15. And this is how you simplify expressions. Simplify expressions. So as you can see, we just show how to simplify expressions. Simplify expressions until minute 10. Okay, so, and this is how you can work it out, simplifying expressions. So you can observe how we can work out expressions, how we can simplify expressions. Look at that here. I just showed you an example of how to convert from algebraic language, identify the operations, how to evaluate expressions using algebra, and how to simplify expressions using like terms and using distributive property when you have parentheses. So this is the idea of what we're doing now. Let's go to the next step, that is solving equations when you construct the function machine. Now, I have observed a little bit of discussions here about how helpful it is to use a function machine. And actually, it's not like something that we must be worried about, but function machine helps you to understand what you're doing. So I'm just going to do the first one to show you. In this case, I need to simplify the expression first. Look at that, I have like terms here. Both have x. Both have x. So I need to simplify the expression first. Before I continue, I need to simplify the expression. 3x plus 5x, $3 plus $5, 3 dogs plus 5 dogs. It's going to give you 8x minus 9 equals 14. Okay, and now I'm going to construct the function machine, because what I want to do is, just give me a second, I need to connect my computer. But maybe you can hear me while I talk. What we need to do meanwhile, you're solving, or when you're trying to do a function machine, is to identify what you're doing. Identify what are the operations that you're applying to the variable in order to get the solution. So the variable is going to be like an input, a variable input, and this input is going to give you an output. In this case, I know the output. So my objective now is that by knowing the output, I want to find out the input. By knowing the output, I want to find out the input. So I'm going to write the function machine in this way. First, I'm going to identify the input. In this case, the input is going to be the x that I put it in red here. So the input is x. And what I do to the input, I'm going to take x and multiply times 8. Okay, times 8. And then I'm going to take this expression, 8 times x, and I'm going to subtract 9. So I'm going to subtract 9 here. And finally, I got the output. With this information, I got the output 14. This is the idea of the function machine. I'll observe how I'm getting the operations of the function machine. And what I'm going to do, if I want to solve this by applying function machine method, is just going backwards to apply the inverse operation in the appropriate order. So look at that, the inverse operation of subtracting 9 is adding 9. So if I take 14 plus 9, it's going to give me 23. And then I'm going to do the inverse operation of multiplying 8, that is dividing by 8. That is going to be 23 over 8. This is how you can use the function machine to solve linear equations. However, you can just, after you do the function machine, you know the function machine, so you know what are the inverse operations I need to apply. So the number that is subtracting here, that is this 9, now must be added, because it must be the inverse operation. It must be the inverse operation on the other side. And I got 8x equals 23. Now, I know by observing my function machine, I know that this 8 is multiplying x, or I know it immediately. So by applying the inverse operation, I can get x. It will be 23 over 8. This is how we can do, we're doing the same idea with different representation of applying the inverse operation. Now, what happens if I have, for example, this one that has parentheses and stuff? So I'm going to create a function machine. The function machine starts with x, the input. What I'm doing to this input, I'm multiplying times 3. And then after I multiply times 3, I'm going to add 1. So plus 1. And after I multiply by 3 and add 1, I'm going to multiply everything by 6. And the answer is 24. So look at that. If I apply the usual method that you can find in books is just applying the inverse operation. But what will be the inverse operation? Look at that, my function machine is telling me what to do. The first thing I need to do is to divide the 6. So it's gonna give me 3x plus 1 equals 24 divided 6. Now, 24 divided by 6 is going to be 4. Now I'm going to apply the inverse operation of adding 1. So I'm going to subtract 1. So I got 3x equals 4 minus 1, that is 3. And now I'm going to apply the inverse operation of multiplying by 3, that is dividing by 3. So x equals 3 divided by 3 is 1. This is how you solve equations using the function machine. And the function machine just gives you the idea, the structure, to know the process of how to solve the equation. If you don't like to go back in the function machine, if you can go back in the function machine to find the answer. And this is how you can work out these type of problems that leads you to solutions of equations. So every time you need to solve equations, I suggest you that if you're learning algebra, I suggest you to identify the function machine first, so you know what are the inverse operations and in which order you need to apply these inverse operations. Because it's not the same that you start the last equation dividing by 6 than dividing by 3. Or it's not the same that you start dividing by 6 like subtracting by 1. You need to identify what are the operations in order. And this is something very, very important when you work out with algebra. This is something that you must keep in mind, you must keep ahead when you work out with algebra. Now, finally, to finish this session of 20 minutes showing you how to work out with algebra, basic algebra, I'm going to finish with what happens if you have a problem-solving situation. But before that, solving equations until minute 17. Now, finally, what I'm going to work out is what happens if you have a problem-solving situation. Solving situations. Now, if you're learning how to solve a situation, I suggest you to always have known and unknown first. Sometimes when we're very good in algebra and we can work out things properly, you don't need to do this step. However, I suggest you that if you need this step, apply it first. Let me see. Okay, now you can see the whole question. Now this is the question. It says that Lena hires a van for moving house. The moving company charges $12 per hour and an additional hire fee of $5. Her bill comes to 101. How many hours did she hire the van for? So the idea first is to identify known and unknown. So what I want you to identify when you read this question is to find out known and unknown. How do you know the known? The known is the simplest because you just need to read the question. And meanwhile you read the question, you need to get where is the data. Hires a van, the moving company charges, look at that, here is one data and the additional fee hired of $5. It comes to 101. Okay, I already find out this data. I'm going to link this data to a magnitude or a quantity. Look at that, it says the moving company charges $12 per hour. So it means that I'm going to use just the same words as are in the situation. Charge per hour. The charge per hour is going to be $12. Okay? Now, an additional higher fee of $5. So I'm going to put here additional higher fee is $5. And now it says her bill comes to 101. Her bill comes to, so it means that the total, right? The total fee is $101, right? So now what I'm going to do is to formulate an equation using this information. Now, you just need to identify the unknown before you do it. And the question tells you the unknown. Look at the unknown is here. It says how many hours did she hire the van? So the unknown, I'm going to put H, is going to be hours hires for the van, right? Now, I want to formulate an equation, so I need to read the information, check the information to know what to do. Look at that here, it says charge per hour. So it means that if I work out 1 hour, it's going to charge me 12, 2 hours, 24, so on and so forth. So the operation I need to do to find out this one, it says per hour, so it means 12H. So 12 times H is going to give me the charge after the hours. And an additional higher fee of $5. And this should give me $101. This is going to be the equation I have to solve. I just need to solve it. You can use the function machine to solve it. H, I multiply H by 12. Then I take and add 5. And I got 101. So I'm going to get back in my function machine. Subtract 5. 101 minus 5 is 96. 96 divided by 12 is 8. So the van was hired for 8 hours. Okay? Now let's say that you did the function machine and you want to solve it like in the usual way that you can see in the book. So the function machine just helps you to know what are the operations you need to do. First, subtract by 5. 101 minus 5, 12 hours equals 96. And now I need to divide by 12. So H equals 96 divided by 12. 96 divided by 12 is 8 hours. Okay? So look at that. I'm doing the same idea with different representation. Let's see this second question before we finish today. So I'm going to just, meanwhile I read, I'm going to highlight the information. Okay? So I have here, I'm going to highlight it in green. So I have 300 students went on a school trip. A bus can transport X students. I'm going to put it in green. 7 buses were filled with the students and 13 students arrived in cars. Find the number of students X a bus can transport. So I'm going to get 300, but what means the 300? The 300 are students that went to the school trip. So students in a school trip is 300. Now, 7 buses were filled. So number of buses are 7. Now, and 13 students arrived in car. Number of students in car, 13. Look at that. Here is students and here is buses. And the question is X. Number of students per bus, right? Now, I already have my known and unknown. Now I'm going to formulate my equation. So how can I get the number of students in the school trip, the 300? I just need to add the 13 students. So I can put like the 300 students of my school trip are going to be the 13 students that arrive in car plus the number of students that arrive in buses. But is X students per bus, I need to multiply by the 7 buses to get the answer. 7x plus 13 equals 300. This is the idea of the number of students. Now I'm going to put my function machine. X times 7. Then I add 13. And this is going to give me 300. So now I'm going to go backwards. So 300 minus 13. 300 minus 13 is 240. 290 minus 3, 287. 287 divided 7, I'm just going to divide it. This is going to be 41, okay? 287 is the same as 280 plus 7, right? So if I divide by 7, this is going to be 40 plus 1, 41. So I can put 41 students per bus. Okay, so, and this is how you can work out problem situations using linear equations. Now, the fact that we use known and unknown is for us to understand the data that we have. This is something of mathematical communication that we need to know, that is how to represent or how to present data in a way that I can read a situation and I find out which is the data that recovers all the information. Okay? Now, everybody, so this is the live session of today. 30 minutes of algebra, 30 minutes of working with these ideas. I hope that these ideas help you to understand more about algebra, help you to understand more how you can cope with these situations, and see you in the next videos. Bye bye, everybody. I hope that you enjoyed this session. I hope that you enjoyed this video. If you don't watch it live, but you watch it later, I hope that it helps you to understand more about the basic of algebra. Leave your questions in the comments, and bye bye. See you. See you soon. See you soon. Bye bye.